Hey, good morning, intermediate algebra students. I believe these are your last two cons that I need to cover for this unit of inequalities and equations. So here's the first one here. I'm only going through one problem. It's actually, they're all about the same type thing. So using inequalities to solve problems. The price of a plane ticket consists of an initial fee of $5. So you can see every equation started with a $5 base fee. Okay, and then we had a stop fee of $2.75 per stop. Julie had $21 to travel 50 kilometers. So she wants to know what's the largest number of stops she can afford to buy a ticket, and then which inequality describes this scenario. So the inequality, we have $5, $2.75, and $21. Here's our equation right here. We start with $5 plus $2.75 per stop. And then Julie has $21, which means we can spend up to $21, but we cannot spend any more. So 5 plus 275s has to be less than or equal to 21. So in this case, it would be our answer right here, this one, letter A. In fact, I can even probably put a little nice little dot on there. Let me give it a fun little color. Oh, let's go gold today. So that being said, nice little gold, and I guess I put a square in there. Isn't that nice? That's an interesting little thing. Anyways, there it is. All right. Now, once we know that, then we can solve this. So first thing we're going to do is we're going to subtract 5 from both sides. We get 2.75s less than or equal to 16. Then we're going to divide, take 21 divided by 16. Let's see, I'll grab my phone right here. 21 divided by 2.75. So 21, oh, not 21, my goodness. 16 divided by 2.75 is 5.818181. So the most I could actually afford while still staying within my budget of $21 is 5. So down here under steps, we would just simply type in the number 5 because that's the most I could afford. So hopefully that makes sense. You're just filling in those. It's not that difficult of a concept. You should get through this one fairly easy, especially if you have me checking your answers every time. The second one that we're doing today is called compound inequalities. Okay, similar to the one above, we're just kind of solving some inequalities. So let's do the first one here. Actually, I'm going to do something so it looks all fancy. There we go. We'll go down to this one again. We'll only make one show up at a time. How cool is that? All right, the magic of video. All right, so on this one, we have, we're going to first solve this side of the equation. So I'm going to subtract 21 from both sides first. So we have negative 18x is greater than negative 36. And then we're going to divide by negative 18. Remember, when we divide, that inequality will flip. So it's x is less than, and let's see, negative 36 divided by negative 18 is positive 2. So x is less than positive 2. So if I actually just take and I put this on our little grid line down below here, I've got positive 2 would be right here, and x is less than that. So if I were to go ahead and draw my little arrow, that would be going that direction right there. Then the next one, all right, I'm going to first add the 13, so 20x is greater than or equal to 40. I then divide by 20, and I get x is greater than or equal to 2. So in this case, on this one, x is greater than or equal to, I need to have a fill color on this one as well. So the other one starts right here on number 2 as well. And it's greater than or equal to, so the line goes this direction. Okay. So this one was x is less than 2. This one was x is greater than or equal to 2. So you can see we've got this. Now, because of the word or up here, because of this word or, it can either satisfy this equation or it can satisfy this equation. If it satisfies one or the other, it's okay. Well, you can see all these numbers satisfy this equation. And then going the other direction, all of these numbers satisfy this equation. So really, there's not one number out there that isn't covered. So this one, if I go back to my nice little handy dandy thing, I think I'm making, oh, there's a circle. It would be all solutions of x work for this one. All right, let me make sure I got that right. I don't think I have that right, guys. Hopefully you caught my mistake. All right, let's do this. I think I made a mistake right here. When I solve this one, when I subtract 21, it should be negative 36. And when I divide by a negative, that goes to, no, it does go to a less than symbol. Less than 2. Nope, I did that correct. So it's all solutions right there. Okay, so we did good. All right, we'll get rid of this dot for a moment. We will get rid of these inequalities for a moment down there. Let's get rid of that whole problem. And let's bring the next problem in here. Now you're going to notice this one is an and problem. So when I solve this one right here, subtract 175, we get negative 25x is greater than 50, divide by negative 25. X is less than negative 2. So that would match with this one right there. Then, once I solve this one, I'm going to add 83 to both sides. So 5x is greater than or equal to 10. Divide by 5, x is greater than or equal to 2, which matches this one. X is greater than or equal to 2. So I still recommend we graph these because it will reduce your pain and misery. X is less than or equal to negative 2, so here's negative 2 right there. X is less than that. So we're going to draw a nice little line going that direction. I'm just going to remove this dot because this will go to one of our answers. Who knows where it'll be. Then we also have to graph this one. X is greater than or equal to 2. So we're going to put the greater than or equal to. We're going to fill in our dot right there. Positive 2 is right here. And we've got to make our inequality. It is greater than or equal to, meaning it goes this direction. So on this one, you will notice that the first equation is an open dot going that direction. The second equation is an open dot going this equation. If this word was an or, meaning it could satisfy this one or it could satisfy this one, then this would have, that would have been our answer right there. But it wasn't an or question. It's an and question, meaning it has to, all solutions have to satisfy this equation and have to satisfy this equation. Well, in this case, these numbers over here satisfy the left equation. These numbers over here satisfy the right equation, but there are no numbers in here that satisfies both the right and the left equation. So in this case, this one would be a no solution one. Hopefully that makes sense, and if you come and get help from me on these, it'll make even more sense. And good luck to you, and we'll have a great day. Bye-bye.